we're really taking that leap, us as a company, Bayer, in cell and gene therapy, which to me is one of these examples where really we're going to make a difference, hopefully, moving forward. There's some, ultimately the mRNA vaccines are an example for that cell and gene therapy. I always like to say, if we had surveyed 2 years ago in the public, would you be willing to take gene or cell therapy and inject it into your body, we would have probably had a 95% refusal rate. I think this pandemic has also opened many people's eyes to innovation in the way that was maybe not possible before. We're really taking that leap.
Okay. So what I wanted to do was address the question. There's obviously been a whole lot of ink spilled over whether or not these are vaccines or not vaccines, whether this is gene therapy or not gene therapy. Now, I have pretty much avoided those discussions because my sense is they are strictly a semantic question. You deliver me the definition and I'll tell you whether that's a vaccine. You deliver me the definition and I'll tell you whether it's gene therapy. And the problem is, if we say these vaccines are gene therapy, that will cause people to think that they are a lot more dangerous. And if we tell people they're not gene therapy, it will cause people to think they're a lot safer. But in fact, whether they are or are not does not adjust their level of safety at all. Right.
And this is an important point, right? And this is a point that gets muddled by postmodernists rather intentionally, I think. Yep. The idea that language itself changes underlying meaning. Language can change the meaning of things, but applying different language to existing things does not mean that that existing thing is A or B, depending on whether or not it's got label A or B on it.
Right. And it's a classic estate tax. Yeah, people are in favor of an estate tax because you're taxing the rich. Death tax sounds like you're kicking somebody when they're down. It's the same tax.
Very down.
So anyway, what I wanted to do was just give people an orientation so they know what the question is. And you can answer for yourself then whether or not this is gene therapy.
But the point again is it's been used as a political football rather than it being...
Right. And I think...
I don't even know. Rather than it...
Let's put it this way. I think the fact that one can argue it either way is the answer to the question. Mm-hmm. This is something very new. Yeah. It's so new that it does not clearly fall within or outside the definition of gene therapy. And I want to just give people enough information to understand what is being described. Mm-hmm. So traditionally, gene therapy, which I think initially goes back, the idea is sort of seeded in the 80s. It's a cool idea, but I would say it's an idea that is overly based in the drawing in your textbook, which is always misleading, right? So if you think about it, there are many disorders or diseases that are the result of a gene being broken in some way, right? Your genes are spelled in some way. They produce proteins. Mind you, I will go back and tell you that the word gene isn't very useful. Genetic is a very useful term. I don't use the term gene very much, but I'll use it here just for shorthand. There are lots of cases in which a gene has taken on a mutation that has disrupted the production of its product and made it harmful. And if the product, let's say there's an enzyme that you need to produce in your liver to detoxify something, and you have a bad spelling of the gene, that will interrupt your ability to produce the enzyme and to detoxify the thing. And if you encounter it, that's bad. Now, in general, these things don't matter every time because you have 2 copies of every gene. And so, you know, in many cases, even if you have a bad spelling, if you have a good spelling, you'll be all right. But when somebody comes into their doctor and they have some kind of a malady, there's a fair percentage of the time that it is the result of the fact that they have maybe gotten 2 bad copies of a gene, or it could be a sex-linked thing where they only have 1 copy to begin with and it's disrupted. But nonetheless, there are lots of cases in which a badly spelled gene disrupts your ability to do something that is part of normal functioning, and it has left you dysfunctional. So, of course, given all of the tools that nature has built for editing genes and things like this, an obvious answer is, well, why don't we just give you a good copy of the gene? And the basic answer to that question, and what I thought when we were first hearing these ideas, I guess we would have first heard them in high school, but college would have been where they came up, was, well, here's the reason that that's not a great plan. It's that you don't have a genome. It's not like a central thing that lives somewhere in you that we can edit. You're 30 trillion cells. And, you know, yeah, maybe if it's a liver gene that we're talking about, you don't need all 30 trillion cells modified. You probably don't need all 100 billion cells in your liver, or however many it might be, several hundred billion cells in your liver. But still, you got to edit awful lot of cells before you've done enough work to actually solve the problem. Even if the cells that you edit work over time, it's still a long way before you've done anything therapeutic.
The genome is highly centralized within the cell, but highly decentralized within the body.
Yeah, that's well said. Okay, so the point is, what gene therapy basically means is, or at least initially basically meant, was you go in, you edit a gene so that the bad product is replaced by a good product and you're no longer sick, or you're less sick. The problem is easier said than done. Right? We do have a lot of tools for editing genes. You can do it in a cell pretty easily. You might be able to deliver it with a syringe to a particular tissue, but how much uptake you're going to get, how much actual useful editing you're going to get, and how much will, you know, maybe you edit a bunch of things well, but in the process, you also disrupt a bunch of things that worked because the editing isn't perfect. Right?
See.
So anyway, the point is, really cool idea, really difficult to do. Okay?
Implementation is going to be tough.
Yeah, implementation is tough. Now, Zach, do you want to put up the FDA's? The FDA has a little explainer site. What is gene therapy? And you can begin to see what the problem is.
Do we know if is this a modern version of it, and has it changed in these last 2 years?
This is the current one. I don't know if it's changed, but it's good enough. If it's changed, it has not changed in a way to...
Actually, it says content current as of July 2018.
Okay, so they haven't changed it then, at least if that's accurate. Okay, so can you scroll down? Okay, stop. So there are a variety of types of gene therapy products, including plasmid DNA, that is circular DNA molecules that can be genetically engineered to carry therapeutic genes into human cells. So plasmids are outside of genomes. They are little units that carry particular instructions. So sometimes antibiotic resistance in bacteria is carried on a plasmid. Those plasmids can be exchanged between critters. So that's the introduction of it. They're talking here about introducing a plasmid that contains a useful gene and not integrating it into the genome, presumably. Viral vectors. Now, viral vectors are capable, in many cases, of introducing genes into a genome. They can actually edit things in. That's one of the things that many viruses do. Now, it turns out coronaviruses do not. But nonetheless, viral vectors is a way you could edit a genome. Bacterial vectors. Bacteria can be modified to prevent them from causing infectious disease, and then they can be used as vectors to carry therapeutic genes into human tissues. Now, that suggests that they are not editing genes at all when they're bacterial vectors. Anyway, well, the point is this...
That's interesting. I wonder if that's an intentional use of that word or if it's just vagaries.
I think the point is, as with the word gene, right? We used to define the word gene, and we said, oh, a gene is that which exists between a start codon and a stop codon, right? And that it encodes a protein. We now know that that's not true. Right? There's something like an average of 5 different edits that you can make of what exists between a start codon and a stop codon. And so each gene may have multiple productive interpretations, right?
You know, I got to say, I've never seen the site before, and this list of 5. So for those just listening, there's actually 5 bullet points, and you just read the first 3. And the fourth one is human gene editing technology. The goals of gene editing are to disrupt harmful genes or to repair mutated genes. And it feels to me like this should not be a unordered 5 bullet point list, but that plasmid DNA, maybe. I know less about what that might do, but viral vectors and bacterial vectors both could be used to effect human gene editing technology. And indeed, human gene editing technology is the thing that people, I think, have in their heads and that they get scared about when they hear gene therapy. Like, that's the thing they worry about most.
Right.
And it's not like these aren't all equivalent. It's like having a list of hypotheses. You're like, no, those aren't alternatives to one another. These 5 things don't strike me as alternatives to one another, even though that's how it's being proposed here.
Well, I think the point is you start out with an idea. People have bad genes that causes disease. We'll edit those genes and make them good. Okay. Then you realize, that's difficult. But there are a lot of things we can do in that neighborhood that might work, right? Like we could maybe we don't have to edit the genome. Maybe we'll put it on a plasmid and we'll introduce the plasmids, and maybe we'll have to do it periodically, but you'll still be better, right? So my point is, if you take a strict interpretation, gene therapy is the editing of your genome to make you healthier or immune or something like this, then these mRNA vaccines are not gene therapy. If you take a broader sensu lato understanding and you say that basically the point is what gene therapy aims to do is to introduce a piece of information into a body such that the body is capable of doing something that it couldn't do before that information was introduced, then in fact, this fits perfectly on that list.
And it does it at the genetic level, as opposed to vaccines are immune therapy. Well, right? You never hear it called that, but that's what they are. And, if gene therapy is any of these bullet points on the FDA, then yeah.
Well, let's put it this way.
Right.
The problem is that a vaccine that introduces an antigen is not gene therapy based on the...
But it's any vaccine that is effective is immune therapy. It's affecting your immune system.
It is affecting...
It's entraining, in fact, your immune system effectively.
But I can make an argument that an attenuated virus vaccine, which is in fact, I would argue, the gold standard of vaccines, is gene therapy by this definition. And I'm not troubled by that. Right. I'm just saying that if the question is, did you introduce something in a genetic form where the product is then causing you to have some capability you didn't have before, right? Then you could make an argument for that one. And so this is why it doesn't really matter, right? It doesn't really matter. But is introducing a virus with genes that then causes the virus to do something that then creates immunity for you, right? Is that vastly different? Or is the plasmid example vastly different than a lipid nanoparticle covered mRNA that gets into your cytoplasm and causes your ribosomes to make a protein as if your nucleus had told it to? No, it's not different at all. This is gene therapy at that level. And so again,
again, who cares at the level of the messaging? Right.
The point is really what ought to alarm you is that we are doing something for which this is a question on which you could argue both sides. And what's really troubling here, as we talked about last week, is that, okay, you're going to introduce something that, you're going to introduce a literal genetic message. Yes, it's RNA, not DNA, but it's a genetic message. You're going to introduce it into the cytoplasms of cells so that they will produce proteins that then trigger something useful. But absent a specific targeting mechanism, absent something that tells cells, you are the cells that should pick up this message and you are cells that should ignore this message. What happens is you have to dump enough of the message in that enough cells pick it up to create enough effect to be worth doing. But that means a lot of cells that are not doing the body any favor by transcribing this message are going to pick it up. And that's the question. The myocarditis that we talked about last week might be, the hypothesis that I put on the table last week was that the heart is picking up these messages, faithfully transcribing them the way the designers of the vaccines hoped. They didn't think it was going to be heart cells, but they didn't provide the lipid nanoparticles or the mechanism for bypassing the heart either, right? So the heart picks it up, transcribes the message. The immune system looks at the heart transcribing foreign messages and thinks that it's virally infected and attacks and kills some of the cells in the heart, which you can't afford to lose because it's your heart and it's not capable of replacing them with similar cells, right? So that's the level of the hazard. Is it gene therapy? The fact that it is arguably gene therapy means that that's the level at which we should be having this conversation. This is not an antigen that was dumped into your system in order to wake up your immune system to a pathogen. This is something much more serious and novel than that. And that's the conversation that needs to be had.